Thank you, Kubab, for the introduction. Let me share my screen and we can get started. Okay, so Kubab, kindly confirm if my screen is visible.
Yes, it is. Thank you.
Thank you. Okay. So today we will work on building a demo, which will be related to creating a voice to content pipeline using LangGraph. So let's start first with the impact of AI in the jobs. So as Bill Gates has said, the development of AI is fundamental as a creation of microprocessor, the personal computer, the internet, and the mobile phone. It will change the way people work, learn, travel, get healthcare, and communicate with each other. So I want to ask that what do we mean by it will change the way the people work? So as we have seen that a lot of technology come in and it actually revolutionizes the work we do. For example, now we have ride-hailing services instead of cabs, and all the cab drivers that used to drive in the 1950s and 1960s have just shifted to ride-hailing services like Uber and Careem. Similarly, before we didn't have many calculators, so people used to manually work on the paper and solve complex problems. Now we have scientific calculators and things like that, which can help us accomplish our task fast. So similarly, AI or artificial intelligence is a tool that can actually help us revolutionize how we work, and it can actually increase our productivity, as Bill Gates have said. So first of all, I want to introduce you guys to the concept of an agent. So what is an agent? Agent is basically a reasoning and decision-making engine, which actually allows us uh, uh, to make rational decisions based on the understanding that it have. What a particular agent does, it actually deconstructs a complex question or complex task into its subparts, and it actually solves the problems and then provides us a concatenated result. So, an agent can be thought of like a reasoning engine, which actually solves the problem and get back to us with the final solution. Now, now let's see why agents are important. Traditionally, we used to write programming programs to compute things, but as our world is evolving, we are shifting from static dynamic decisions that require us. Agents are our thinking engines, which actually enable us to make those decisions based on the rationale that we have gathered as a humankind. So agents actually help us automate the complex task, and it actually performs a dynamic decision making that allows us to make the decisions. For example, let's take an example of a help desk solution. If an agent is to replace the help desk, it should be intelligent enough to think and decide whether this query should go to the FAQ response and whether we have a response for this, or it should be escalated for a human to take intervention in it. So LLMs are actually transforming to agents now. Before agents, we have the concept of chatbots. So chatbots are the agents that actually only can provide us the feedback and the conversation and the chat, and it actually provide a conversational interface where we can chat. But now in the concept of agent are used to perform the actions. Now the dimension have shifted from the chatting perspective to doing perspective, where the agent will perform actions. In this domain, uh, there is a lot of unreliability that we have with the agents. For example, we have seen that, for example, we have when we are using a chat GPT or any tool which involves LLM, it provides a different output every time we ask the same question. This is due to the probabilistic nature of the agents. Now, the concept of the structured output is here to help us mitigate this problem. Now, what the concept of structured output does, it actually allows us to define the schema or a proper format that we can give to our LLM, and it is intelligent enough to provide the result in this form. For example, to use agents in our daily life scenarios, and to make the robust solutions, we need some specific output in some specific structure. It can be a list, it can be a table, it can be a JSON. we can define in what form we expect the outcome to be. For example, like here's a sentence, I'm Lance and I like to bike. Now, as a human, I can understand all the parts of speech that are given in this sentence. For example, Lance is a noun, he can be a person. Bike is an object, and like is a verb. Like I understand the semantics of the sentence. In a similar way, LLM also understands the semantics of the sentence, and we can define a schema or a structure that can be used to provide output that we like. For example, I can attach an schema here where I can define what things do I need from the LLM. Like I can ask it to find the name or maybe interest, so it can whenever it will provide me the output, it will make sure that it should include the name and the interest of the person in the output. Like in my case, Lance the name. So I have attached a schema definition which tell it to extract the person name if it is given. Now, for example, if here it is I'm John and I like to cook, so John is a name. So it will give me a name as John, and it you can see it is providing me the output in the form of a JSON or dictionary that actually enables me to use it further in my workflow where I require this particular dictionary or this particular data type. LLM structured output actually have enabled us to make more robust applications. In the same domain, we have LangGraph. So, as we know that since ChatGPT and other LLMs came into the market, there's an open source market that is evolving side by side, led by LangChain. So, LangChain actually provides us a lot of tools that allow us to build solutions over the LLMs. So, one such solution or one such framework that LangChain actually proposed is called LangGraph. So what LangGraph is, it's a framework for building graph-based workflows in LangChain. It actually applied the old concept of graphs that we have already studied in the computer science to the concept of LLMs, which allowed us to build a robust solutions and which allowed us to solve solutions that involve complex reasoning and multiple decision-making tasks that is beyond the conversational agents. In the conversational agents, the flow used to be simple. User can ask a query and it will get a response. He can ask a follow-up query and he can get a response. So the flow was simple. User can say one thing, LLM will say another. User will say one thing and LLM will say another. But now, as we want to solve more robust problems and more complex problems, we require more robust solutions, which involve decision making and error handling as well. Because sometimes, let's say, um, I can have a tool which perform a specific action. Like if I go back, I have an input, I am Lance and I like to bike. So it will give me an output name, Lance and interest biking. For example, if I say I like to bike, now in this sentence you can say there is no name, so it will give me an empty name. That's how it is actually in handling the output by itself, and it is doing the error handling rationally. So this is possible because of the frameworks like LangGraph, which allows us to handle the mistakes that LLM make, and it actually handles the mistake elegantly such that the solution that we are building do not break. Okay, so how the LangGraph actually imagines the workflow to be? It actually imagines the workflow to be in the form of a graph where each node actually performs where each node actually defines a decision or a defines the edges. You can see here uh, there's a person, okay, and when this person provides a query which a user request, then our LLM decides and plans that what should be the task list and what the person wants. For example, if I want to write a blog, there can be multiple tasks about writing a blog that can be. For example, I want to research and find out the sources that are relevant. It can be from YouTube, it can be from web links or any other sources to get the inspiration from. Then actually I have to rewrite the blog and I have to put in my original ideas as well uh, to perform a blog. Now, as I have written the sections, I have to recompile those sections into a complete blog such that the story seems coherent. LangChain actually allows us to build such solutions by providing us complex error handling and complex reason and decision making techniques. Now there are few components of LangChain that actually allows us to build a LangGraph. Okay, so as the name suggests, we are going to build a graph from these components. So now, to build a graph, there are four things. There are nodes, edges, conditional edges, and state. So nodes, as we define, nodes can be the steps. Like for example, here the user give a query, so it starts. Okay, now we are at the planning stage, so it's a node. Now we are at the worker stage, which is performing the task, and we have a solver, or you can say a compiler, which actually compiles the whole block. So it's a node, right? Similarly, we have edges, right? You can see whenever a user gives some query, it goes to the planner, and whenever a plan is constructed, it goes to the worker. Then when a worker actually writes a section, it goes to the solver. So you can see there is a line the line indicating the flow of information between the nodes. So this is done through edges. So they are the dynamic, and as you can see here, the nodes are connected through the edges, right? But there can be complex scenarios in which there can be edges which can be conditional. For example, let's say if we are working in a complex if we are working in an office, for example, maybe we can perform some tasks, we can write a blog. It may be incomplete, it can be incomplete. So our manager can say you should rewrite this blog, or you should incorporate this feedback in it. So it's incomplete. So you can see here there's a concept of conditional edges as well. Okay, which can evaluate output that is coming from the previous node, and it can decide where node. For example, you can see here there's a conditional edge involved here as well. Loop to solve task. For example, uh, given the plan, it has written some blog, right? But this section of the blog is not good enough, or it may actually not involve the not involve the structured output that we have given. So we can rewrite, or we can solve this problem again. This should be done using the conditional edges, where a condition is involved which decides that what should be next state of the graph. Okay. So, as we actually perform the whole workflow, there needs to be a space where whole information needs to be stored while we perform a task. For example, you can see here, whenever user gives some query, there will be a question, right? And whenever the planner gives some plan, there will be a plan output, right? And whenever there will be a plan, it should, when it is being worked on, output is generated in the form of a block section. So you will see that all of this information that we need to keep our, in our graph, we keep it in our state, and state acts as our memory. So giving you guys a recap, what nodes perform, nodes are our thinking engine, or you can say they are complex problem solving engines, right? And edges actually connects these problem solving engines. And edges can be of two types. They can be simple static edges, or they can be dynamic or conditional edges. And condition edges actually work on the concept of conditions, and it evaluates an output that is coming from a previous node onto a specific condition, and it decides whether which node to go on next. And state is the information that we need uh, to move in our graph. Now, now focusing on the theme of this particular webinar, we will be going through the concept of word graph and voice to content pipeline. This is inspired from the concept of RoboBlogger, which is presented by LangChain. And how it will work is that we will first give it our thoughts, or our context that we have in the form of a voice input. Then GPT-4o will decide, okay, so this blog will have this sections, and then it will give it a plan, and then it will decide a plan to work on the different sections. Okay, sections can be intro to the blog, then it can emphasize on particular topics, then it can write all the blog, and then it will recompile all the blog. uh, But in this section, we will also be incorporating the how we can incorporate the web-based knowledge. I mean the web links or the websites, not blogs that we have, and the YouTube videos that actually help us write a blog. So our pipeline should look something like this. There will be a user, okay, and which will provide a query in the form of a voice, which will be their ideas of how they want to write a blog, right? And then these ideas will be converted into a form of a text, right? Whatever I will speak will be converted by a speech recognition model into a text or a transcript of my ideas. Then these ideas will be given to my planner node. Here, this will be a node, right? This planning node will actually contain the logic, which will decide that what should my blog look like. Okay. Then it will generate a plan for each section, right? There can be multiple block sections. There can be intro, there can be section one, there can be section two, and there can be conclusion, right? This is the structure that we can define. It actually utilizes the concept that we have studied here, right? The concept of a structured output. Like in each section of the block, we can define that, okay, so this section must have an heading, it must have an outro, it must have some content, it must have a theme, things like that. Okay, so we can define sections with their respective blog structure, right? And optionally, we can also give it the links, right? The links can be the YouTube links to the YouTube videos, or it can be links to other blogs where we are taking the inspiration from, right? And then it will write each of the sections in parallel. And when this writing will be done, it will give us a final report which will be our final blog, right? So this you can see there are arrows which define the edges, right? So there is the edge coming from user to transcript, which actually transforms our user spoken voice to in a text file. Then the text file which will be given to the planner node, and planner node has edges which actually converts the whole blog into its sections, and then each section will be processed by a writing node, which will actually write the blog one by one each, and then all of the sections are written in parallel, and then they will again be compiled to build a final report out of all the sections of the blocks. Okay, so now I think we can move towards how this graph will look like. So you can see here all of these shapes, like this oval shape and this rectangle, these are the nodes, right, of a graph. There's a start node. Whenever a user will provide a query, it actually acts as our start node, right? And then our planner will generate a block plan, and this block plan will tell us that what will be the sections of our blog, right? What will be the heading of a blog, what will be the theme of a blog, what will be the intro, what will be the outro, things like that, right? And then each of the sections will be written by a worker node that will write each section. Now there can be multiple sections in a blog, and these once these all of these sections are written, we will gather uh, these completed sections, right? Uh, and we will write a final section later. Now, the logic behind writing a final section and is that since we need our block to be very coherent, the final section should mention the information that we have described above in our blog, right? Once we have all of our, so you can see here, most of the writing will be done in parallel here, like intro, section one, section two. These things will be done in parallel. But our final section should involve a summary of all of these sections that should be written, right? So that's why we are writing this particular section in the very end of the block. And once all of this task, all of these things will be done, uh, we will write a complete final block. Okay, so this will contain all the sections that we have written so far, and our intro and our outro. All of it will be combined to generate a final block, right? And then our graph will end. So you can see there are multiple nodes, okay? And these nodes are connected by edges, right? There are no conditional edges in our graph so far, right? The nodes are connected with the static edges, right? And from node start node, we are going to the generate block plan node. And from the generate block plan node, we are writing each sections in parallel. And then once the sections are completed, we are gathering those sections and writing a final section from these from all of these uh, previously written sections. And now we are completely generating a final block out of all of the written information that we have. Okay. So now also we will be using since we are actually incorporating a voice capture input, so we need to utilize a library from open source provided by Google, where we can actually give it a voice input and it will recognize our input, and it will convert that input into text, right? And the original demo by the LangChain actually uses the Anthropic Claude, uh, and we will be using the GPT-4o. Okay. Now let's look at the code. I'll be using this code from here from the RoboBlogger. Let's actually take a look what this code contains. So first of all, I can create a new folder here. But can you confirm is my coding screen visible?
I think it's stuck, Fazan.
It's stuck. Okay,
Yeah.
let me share it again.
Can you share it again?
Sure, sure. Is it visible now? Go back.
I think it's still stuck for me.
Okay, let me reshare my screen.
Yeah, can you reshare? I think it will be okay then.
Sure, sure. I think it should be visible now.
Yeah, it's visible now.
Okay. So to start on the coding part, what we have to do, we can actually create a new terminal here, right? And since we are using a RoboBlogger that is given by LangChain, what we can do, we can simply write a command to git clone, and we can provide this URL. So it will get the code from this particular GitHub post to my VS Code. Okay. So to define the structure of the blog, I'll be copying this particular folder of agent that we will be using in our demo today here outside. We do not need anything else from here. Okay. Okay. So now let's look at the folder structure here, right? So you can see, first of all, there is some configuration, right? This configuration can be, you can also change this configuration to define how your block should look like, right? And this particular structure that is presented by LangChain, they have they have strictly written three parts for a block, right? They have defined that there should be an intro, right? There should be a main body, right? And there should be a conclusion. Main body can have 2 to 3 sections, and for each section they have given some guidelines, right? That for example, introduction should mention the key links, right? And there should be a problem statement that we are going to solve, and they have also defined the word limit here, that uh, according to which this particular section will be formatted. And then there are main body, right? And there are 2 to 3 sections in the main body, and each will cover a different aspect of the main topic that I asked to write a blog on. And there should be no overlap between sections to avoid repetition. Now, in the end, there should be a conclusion section, and it should also contain the key links that we have provided and clear call to action. So this is the basic structure that LangChain has provided for the blog, right? Now going to the graph, this file actually contains all of the important parts that are needed to build our demo, right? And because it is the file that is actually doing all the heavy lifting of the code, right? So by default, they're using Claude from Anthropic, and we will replace it with GPT-4o. So now let's first look at the structure of the code that is here. So first of all, they have written a function called generate block plan. Now there's a file that is being referred here, which is called transcribe notes file, right? Whenever I will speak something, it will sit in this folder, and it will be in this kind of a text, right? So there is some text already here. Okay. So what this particular file of graph is doing, it is actually uh, taking the file, okay, and it's actually getting the text from this file, and 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 it is using these instructions to build a prompt, first of all, for this section, for the planner, and planner will decide that what should be the sections of my blog, right? And we are actually running it with the structured output. As I have mentioned, we have defined a particular structure for every section. So if I go to this particular area, you can see here is the structure of a section that's defined, right? You can see there are different fields, right? There's a field of name, there's a field of description, content, and main body, right? For every block. And what planner node does, it actually gives each section a name. It provides what should this section contain, right? And uh, it also tells us that whether it's a main body section or an intro or out. Okay, I will tell you why it is important later. And these sections will be contained of multiple sections. So, okay, so there is a section and there will be multiple sections in our blog, right? So in our blog state, when we start, we have multiple things. We have a file which will contain our voice input, right? We have the URLs that we will be giving to generate a blog. We will be having sections that we have to write. We will have completed sections that we have already written so far, and we have a final blog at the end, right? And here I am defining my input and output, right? My input will be a dictation file that I will give after converting my voice into text, right? And I will also be giving a list of URLs that will be YouTube links and the web links. And my output, as I define here, is a final blog, right? Final blog will be my main output that I should be displaying on my screen. Uh, now let's look at the prompts. Okay, so prompts are the building blocks of our LLM, right? As it actually tell the LLM what to do, right? So we have a block planner instructions here. So this is the main prompt which decides that how our blog will be structured and how it will be planned. So it tells the planner that you are an expert technical writer helping to plan a blog post. And what the planner does, it actually provides us three things, right? It actually provides a name, description, and main body. It do not write anything in the content. This will be the job of the writer, right? This should not be done by the planner. It only plans that what should be the section of my blog, and what should be the description of the blog. So this description and name will assist the writer that we will see later to generate a particular section. And it actually also confirms that our blog is following this blog structure that we have defined in our configuration. Now, moreover, you can see in the prompts that we are also giving it user instructions that we will be giving in the form of a speech to define how it should work, and what should be the main topic, and what the blog should revolve around. Now there is a main body section writer. Now this is our worker node which will perform the work that planner will assign into it. Its job is to write each section, right? It will be given the user instruction, section name, section topic, and source URLs. So section name and section topic will be assigned by the planner. planner will tell this worker node that, okay, so you have to write this section. The name of this section is this and its topic is this. Okay. And it has also given it some guidelines that it should follow while writing a blog section. So it has tell us to use this specific markdown formatting for proper displaying in the form of formats. And also there is a separate prompt for writing a conclusion. As I actually told you guys that that our conclusion will be written at the end. So you can see here, this conclusion section will also contain the uh, all the sections that we have written so far. You can see here there's a placeholder for main body sections. This will tell us, okay, so these so the upper part will write all the specific sections of the block. And now this particular prompt will help us write the conclusion and introduction of the block. Okay. uh, Now going back to the graph. So as I mentioned that we will be using GPT-4o, so we have to make a couple of changes here, right? We can go and replace that LangChain. Okay, so before we build a project, we have few dependencies that we need to install in our computer to run this demo. And I can mention these as in the requirements file, so you guys can work on it as well. So our requirement.txt will be containing all the requirements that we have for building this demo. Uh, this is related to the LangChain library that we need. Also, we have the env.example file that is for the Anthropic that we have. But now as we will be using OpenAI API key, so it should look like this, OpenAI API key, and you should be giving your API key here instead of this. So similarly, I can actually write a env file for myself, right? And I can copy it here in the folder of agent. So now it will have my OpenAI key. Now, this whole structure that we have discussed so far, it actually is the back end of our solution. Now we have to write an Streamlit application that will help us show our block on the UI. Now I can start a file which I will name app.py. Now I have created a new file which I have written app.py. And also there are a couple of changes that we have to do here in the graph one, right? As I mentioned that we'll be using GPT-4o, so we have to use LangChain OpenAI. And instead of Anthropic, we will be using Chat OpenAI. And our model will be GPT-4o. So this is the change that we needed to do this in this file. Also, as I mentioned, this particular demo that LangChain had made, it all only involves loading the web links. But as our demo is an extended version of it, we will be also exploring how how we can also incorporate the YouTube links here. So to do that, what I have to do, I have to add a YouTube loader here. And I should be using this YouTube loader after I have written all the URLs. So you can see I'm reading the file from the location that is given my URL, and it will give me the subtitles, or you can say the captions of my YouTube video, and I will use it as the source knowledge for creating my blog. Now these were the two changes that we needed in our agent folder to run our demo. Now I will be starting to work on the Streamlit app that will act as our UI. So first of all, we need Streamlit. Okay. So I will import it, and Also, we will be needing a speech recognition library. And from the agent folder, we will be needing the graph module that we have from agent.graph. We will import graph. And now I am writing a function to recognize my speech. This part I'll be taking an input from the user as source, right? And I'll be displaying on the Streamlit that, okay, so I'm taking an input and it should display on the Streamlit too. Now I have to start listening to what the user is saying. And there's a function that we need to run so that it reduces the noise that is coming from the environment, right? And it starts listening from this. Okay. Now we will be try listening, and whatever we will listen, we will recognize it with the help of recognize.google function. Recognize Google function. Okay. Also, we will be handling any errors that are generated while recognizing this with the accept body. Now we will write our Streamlit app. So first of all, in our Streamlit app, we will need a title for the Streamlit application. Then we will be needing a text area to display a space where we can input the links, which can be our YouTube links or web links, right? Then whatever a user is speaking, we have to store it in the form of a in the form of a text area, right? And when a user starts speaking, we need to run this function of recognize speech uh, and to allow the function and to allow the Streamlit app to recognize the input that is coming from the user. Now, once we have the input ready, what we can do, we can actually we can store this particular input that we have in our speech text variable. Now, once we have all the inputs ready, which includes our URLs and and our speech or with or our thoughts to write the blog, we can press the submit button, which will help us finalize our blog. And what we have to do, you can see we have to separate all the links that are given by the user and provide them as an input to our graph file. Okay, so you can see I am invoking my graph with two things, URLs and transcribed notes file. And as I am recognizing a speech, I'll be saving it into this particular file of notes.txt, right? You can see I'm storing it here in a file. And then I'll be reading this file to recognize what the user has said and what are the links that he has provided to write a final blog. And then once a blog will be generated, I'll be displaying it on my UI. So if we visit the graph structure again once, I can show you how this particular graph is working. So you can see here, there's a generate block plan function, which will work and generate a block plan for our blog. and it will provide us the sections that we need to generate our whole block, right? And then there will be a writer function that will be writing the block one by one, section by section, and it will be based on it will be doing it for one section at a time, right? And then there will be a final sections function that will actually write the outro or the conclusion of our block. And uh, it actually will involve all the already written block sections as well that we have previously written. Now, this send request will initiate or trigger our writing process. And once this is done, we will gather all the completed sections here. And once it is all done, we will compile the whole block in by using our compile block function. And this will be given to the end user. Now you can see here's the thing that we have been talking about regarding the structure of the graph. You can see here the generate block plan is a node, and it works in the function of the generate block plan. And add node is a and we are adding another node which will be writing sections. Then we'll be adding another node which will compile the final block, and then we are completing the sections. Okay, and then we are writing the final section. Now these are the nodes that that we have defined, right? But we also need to connect these nodes. So these nodes are connected here by using the edges, right? We will be starting the knitting a block plan. Then after the knitting a block plan, we will be moving uh we will be moving towards the writing section process. And in the writing section process, after the writing section, we will be completing the block by gathering those sections. And once we have those sections ready, we will write a final section if it is not already written, right? And then once it is written, we will compile all of our blog here, right? And we will provide it to our end user, and we will end our graph. So you can see here, it all starts from the state graph here. We provides our current state, we provide our input, we provide our output, and we provide our schema. Okay. Our schema will define that what should be the format of our blog, right? And in the end, we are actually compiling our whole blog. Okay, so now as our code is ready, I can go to this particular file app.py, right? And I can write streamlit run app.py. Uh, Web, can you confirm is my application visible?
Yeah, it is visible.
Okay. 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 So I have not set the OpenAI key yet. So I will be setting an OpenAI key. So after setting the OpenAI key, it should work fine. Let's reload the page. Okay, now you can see here, it actually is asking me for the links, right, which I can provide. Let's say if I want to write a blog on cold calling, I can search for some blogs regarding cold calling, and let's make it some specific cold calling in sales, maybe. I can search a couple of blogs related to this. I can use this link here, right? I can browse to a YouTube video. that contains some information about cold calling. I can pick any video from here too, right? And I can copy its link to our application. And now I can record my voice. I want to write a blog on cold calling on B2B sales. So it has recognized my voice. I can fill it anything that it has missed, right? Uh, and how to reach on businesses. I can complete this thing, right? And I can click on submit. And once I click on submit button, it should read a file where my input is already there, right? And it should be giving me a response. Now, meanwhile, it's generating a response. I can show you guys that how it actually changed the file that I had. Uh, so if my screen is visible, you can see here that there's a node.txt file which now contains the input that I have given it as a voice. And now it will be using this input to generate a blog. Now let me see. Okay, now I can show you guys that there's a blog that we have here. This is generated, right? You can see it has generated a proper blog, which all with all the sections that are in a blog. That like it has an introduction, right? It has different sections, each focusing on the different aspects of cold calling, right? It has also given me a code to automate the whole pipeline of writing the CRM tool. And it has also given me a technique that I can use to make a perfect cold call script. And in the end, it also has given us this conclusion that we have described in our prompts, right? And there are also links here which I can browse to go on to the YouTube video and the web link that I have provided. We can try a couple of more scenarios as well. Let's say uh, I can write how to handle conflicts in corporate. I can now give it another topic, let's say, and I can provide a different video, or maybe I can skip a video and I can say, write a blog on how to handle conflicts in corporate. Write a blog on how to handle conflicts. Can actually write my words here as well. Okay, and when I click submit, it will process the input and it will generate a blog for me in a couple of minutes. Now you can see here's my generated blog on managing the conflicts in the corporate. Now, you can also deploy this solution if you want to use it on the Streamlit by using this button. Now coming back to our slides, actually there can be improvements that we can do in this particular solution. And for example, currently we have this node where we are actually generating the blog, right? Now there can be another node which can be a reflection node which can come at the very end, and it can reflect on the whole block, and it will analyze the block, and it can rate a block at how well a written block is, and it can rework on the block to emphasize on what are the shortcomings that can be improved. So in this manner, we can improve this demo further. Uh, but that's all from my side. We can actually start taking the Q&A, if any.
Uh, Thank you so much for a very detailed presentation, Fazan. We'll be taking the questions now. If you guys have any questions, feel free to ask right now.
Yes, actually, Erica, the repo is already on the LangChain GitHub. We can share the link. I can drop the link in the chat. Sure, sure.
Perfect. So meanwhile, if you guys have any questions, feel free to drop in. I'll be sharing my screen and let you guys know about our Discord community server, in which, of course, it will be of high relevance for you guys as well, since we share exclusive resources here and the resources that are not commonly known to our platforms. And moreover, our upcoming live webinars are all up to date in this server. So you will also get the recordings of this session and the previous sessions all uploaded here. The YouTube links will be added, and you can always refer back to this session anytime you want. So feel free to join the Discord server. The link will be shared in the chat below, and you'll be getting the access of all of our events as well as our exclusive resources, and then of course our exciting giveaways that we hold for conferences. Feel free to join the server and get in touch with the aspiring data scientists. So if we don't have any questions anymore, so yeah, I'll formally conclude the session. I think we do have one question. Where did you deploy? Can we deploy in local? If I'm not right. Yeah.
Okay, okay.
Yeah, yeah.
So someone has asked about the deployment. We have used it locally on with our Streamlit. Okay, and if you want to deploy it, you can also deploy it on a Streamlit cloud, where you can showcase it to your friends or anyone you want to demo. They will have it up and running on with them as well.